the discussion of this question is in terms of the dynamics of an object which is undergoing a movement up and falling down only under the influence of gravity. Okay, so imagine a situation in which you have a sort of a ball in your hand and you throw the ball straight upwards.
That looks as if he's doing shot put.
As best as you can. Yeah, it looks like it's the size of a shot put, but it's okay. I have to show it like it's that big. So now let's say that a little bit later the ball is just about to leave your hand. Okay, so kind of like imagine that there's a sort of motion going on over there. So the ball is just going to leave your hand. So at that point, so to say, when you're about to let go of the hand, let go of the ball, not the hand.
Sir, are you wearing a cap?
Yeah, I am. I forgot.
See it.
I came down in this. It is a bit sunny, so I wore a cap and I forgot to remove it.
The sun came again, huh? In CLT, you said
yeah,
it was not sunny.
In the afternoon, it did, yeah. And just at that point when it is about to leave your hand, this ball had some upward velocity, right? It will have an upward velocity, and well, the question that we just answered is saying 20 meters per second, but let's take 30 meters per second. Okay, so you are pushing the ball upwards and it's at a speed of about 30 meters per second just before it left your hand. Okay, now looking at the rest of the ball's path, the ball is obviously going to go up, let's say like that, then like that, and like that, and of course it is going to fall back in the same way. Now because I would like to show the upward trajectory and the downward trajectory in different ways, I'll just draw this out a little bit so it looks like a curved path rather than a straight up and down path, but I mean to say mainly the straight up and down path. For interest of illustration, I'll just show it as a curved path. Okay, so the ball goes up and then it kind of comes down.
What is trajectory?
A trajectory is path or the path of movement of an object. Hey, you have Google, man, Google it and find out, don't ask me. Okay, so the path of the object is kind of like that. Okay, so this is the upward journey and this is the downward journey. So some simple thing, the situation is pretty simple. Then what it asks is, can you predict some things about the movement of this object based on the information that has already been given to you? So let us kind of explore this. Okay, so if you want to ask some questions, make some predictions, you can do that. I'll note all those things down and then we will examine the reasons of why those predictions are made or why they have to be true, and perhaps in some situations also say why they cannot be true. So what are your predictions or what are your questions? So okay, let me put one thing at least. The question is, what about acceleration due to gravity? So we have to say that acceleration due to gravity is approximately 10 meters per second square. So that is a given. Now predictions or questions, whatever you like.
Yeah, I have a prediction. So after...
Wait, let me get a list of people's names so that I don't miss anybody in the bargain. So Ishan is there already. Fine, you have started to speak. Next is, I can see Nilofer.
Me. Then
Sneh. Then?
Sir, me.
Name please. I'm not able.
Singh.
Sorry?
Raju.
Siddharth Singh.
Sid, okay. Anybody else?
Anadya is raising her hand in the participants box.
Anadya. I think I missed out a letter. It's okay. You get the point.
Yeah.
No, you haven't.
Is that it? 5 people. Okay, Ishan, go ahead.
Yeah, so
Say
after
if it's a question or a prediction. Okay.
it's a prediction.
Okay.
Yeah, so after 1 second, it will have the same speed as after 3 seconds after leaving my hand.
Okay. Okay. Yes.
Yeah,
Wait,
and also
what?
which would be 10 meters per second.
Okay.
Wait, I didn't understand.
He's just
Ishan's
predicting.
prediction.
He's just predicting. We will interrogate him later on.
Oh, okay.
Let's just get all the predictions down.
Sir, even I would like to predict. Can you add my name?
Who's that?
Rihita.
I got disconnected. What is the list?
List is the list of people who want to make a prediction about the motion of this object, or they want to ask a question about to clarify what we are supposed to do. Basically, I'm saying that there is a ball, you know all that, right? Being thrown up 30 meters per second takes this path.
I just got disconnected when you were making the list.
Yeah, just the names of people who are going to make prediction. Ishan made the first prediction. He's saying the speed at 1 second after it left the hand and 3 seconds after it left the hand is going to be the same, and it's going to be 10 meters per second. And I have a question about this part, but anyway, we'll come to that. Yeah, you were saying something else, Ishan.
Wait, sir. Sir, I
Yes?
have something against Ishan.
No, not now. We'll take up a discussion later. Nilofer, you go ahead. Give your prediction or your question.
After when it's 3 seconds, it will be it'll be 0 meters per second.
After 3 seconds, it will be okay. Okay.
Oh, sorry, I galti se said that wala question ka answer.
That's what.
You can modify it.
Yeah.
Okay, fine, I'm modifying it.
Change it. What do you have to? What needs to be changed?
After 2 seconds and 5 seconds.
Okay. Okay.
Also,
Ah.
also after 1 second and 6 seconds.
Okay. So there is a pattern. All right.
Yeah.
Okay. Snehashish?
So the speed of the ball will be 30 meters per second when it comes to the height it was released at.
At same height. On down path, right?
Yeah.
Okay.
Sir,
Yeah.
I think that when it's going up, 10 meters per second from the speed is decreasing, and when it's going down, it's adding.
Okay. That is a more fundamental point. Correct. Decreasing on way up and increasing on way down. Nice point said. Anadia?
Okay, so mine is that when it's going up, it can the same speed. Like you made that now, so like when it's next to each other, like the top, like the second last one will be 10 while coming up and going down.
This point. Yeah, but I did not make those points in any particular for any particular reason. Would you like to say something more specific? You are saying the velocity of the ball on the way up
I mean,
will be 10 meters per second at some
at
point.
the time, like
Yeah.
so it's like when it's at 1 second and
No, 1 second after it has left his hand, or 1 second before the top part, or 1 second before it comes down.
1 second after it has left and 1 second before it has come down. It will be the same.
1 second. Okay, t is
She's
equal to 1.
saying 1 second after it has left his hand, and 1 second after the ball has come to a momentarily stop
Yeah.
is the same.
Ooh.
No.
Yeah, after while it's coming down, the first 1 second ka slot and the first.
Okay, let us say that this is time t is equal to 1 second. After leaving the hand, t is equal to 0 second. So what are you saying about this?
I'm saying equal to 1 second, and then and 3 seconds will be the same.
1 second and 3 second will be the same. So 1 second
Actually,
after.
wait,
Uh,
I'm getting confused.
No. I think you please make sure that you are clear about what you're saying. Put it in a statement. Have a look at it, and then make
I'll
the
think
statement.
about it.
No. Your statement
Sir,
doesn't seem convincing. It's too confusing.
Yeah.
Maybe you
So
can
can you
type
please
it.
look at the chat?
Maybe you can type it and send it through chat. Okay, Shrita.
Sir, yeah.
can I say something?
One sec. Can you read the third prediction out loud?
Third prediction is velocity will be 30 meters per second at the same height as the hand on down path. I mean, I've just kind of paraphrased what she said, but basically what is being said, what he said, but basically what he's saying is at this point when the ball is falling down, it will have exactly the same velocity as it was going up.
Okay.
I have.
Wait, so
Sir.
I have something against Ishan's thing.
1 second, not yet. Shrita still hasn't said what she has to say.
Yeah, so mine is same as Sneha, Siddharth, and Nilofar. So when the ball is chucked up, after 1 second, after the ball is chucked, it will be 20 meters per second. Then again, after another second, it will reduce again and it will be 10 meters per second. And then when again it will become 0, and then again while coming down, it will gain 10 meters per second. So basically, when it will come down again, like Sneha's point, it will be 30 meters per second.
Yeah. Okay.
Yeah.
Okay.
Sir.
Yes.
Sir.
Uh,
Sir, even
uh,
Okay, Anadia. Fine.
So could you please look at the chat?
Yeah, I
sir,
am.
can I say something?
I am looking.
Sure, I agree with Shrita.
Sir, can I say something?
Okay.
Can I also
once
say
again,
something?
let me just clarify.
That's what.
Let me just look at everything that is there in the chat, and then no, it's okay. There may be some mistakes in the statements that they have made. We will clean it up as we go. Anyway, okay. Ishan has made the correction. It will be same at 2 and 4. Okay. Nilofer wants to make a point. Prakriti wants to say something. Anadia said that her point and other people's points are similar, so she's withdrawing. So okay, kind of what Shrita is saying. Okay, Prakriti, if you want to say, and Nilofer, your last point.
So the acceleration of the ball should be the same when it goes up and when it comes down after it stops at rest, and
Very
when
good.
it comes down the acceleration will be the same.
Okay, very good. But we had made that statement that the acceleration is going to be the same. But yes, acceleration is the same for up and down. It can't be different.
Yeah.
What?
Yeah.
Yeah, it is.
Should be the same.
No, sir.
Acceleration
Like,
due to gravity is the same every time. So it's a little bit, it seems to be a little bit confusing, but I think that's an important statement to make. And Nilofer, if you want to make the last point, then we will start the discussion.
Yeah. So I think when you throw it up, it decreases by 10 meters per second square because the amount of gravity acting on it rounded off is 10 meters per second.
10 meters per second square. Well, gravity is a force, so we do not know about that very clearly as yet. We haven't discussed it basically, but what we know is there is an acceleration. Okay, and when the object is going upwards, it's going to slow it down because the gravity is pulling in the opposite direction. So therefore, it's going slower, 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 comes to 0 and then starts falling. Okay.
Yeah, that's what.
All right. So, well,
Sir,
maybe I can paraphrase your point as point like this: deceleration on up and acceleration. I think that's what this fourth point is about.
Sir, what is deceleration on up?
Deacceleration.
It's the opposite of.
Opposite of acceleration. Correct.
No.
So let's try and put all these
Sir?
points together. Quite a good set of observations to work with. So let's see how we can understand this. Sorry, was there anybody trying to say something?
Yeah, sir. Sir, in the first point, sir, the acceleration won't be 10 meters per second.
Square. Why?
No, sir.
No,
That's
sir,
just the
changed
gravity,
it.
no?
2 and
This, you mean the velocity will not be. Speed at
Yeah,
That's
sir.
not the
Sorry.
velocity, that's the speed.
speed at 2 and 4. 1, 2, yeah, it will be this. It will be the same.
It will be the same.
Huh?
Oh, I didn't realize you had changed it
Okay.
to
Okay.
4.
All right. I thought you were looking at your notes. Okay, got it. Okay, so great. I hope most of you were following what people were saying because in a way, whatever has been said sums up the entire thing quite well. It comes out as observations made by people about the motion of this object, and it's more or less correct. So let us examine some of these things. Some of these statements need a little bit of tweaking. It may be because of the way I noted it down, or maybe you said it, but whatever it is, we'll arrive at the correct conclusions. So yes, one important thing is that when the object's going upwards, the acceleration is always acting downwards. Okay, so the acceleration, that is the force which is causing the object to slow down, is always acting in this direction, and it is always equal to 10 meters per second square. And in other words, if it's a little confusing, think of it as 10 meters per second. Okay, so if the ball left the hand at the speed of 30 meters per second, take it 1 second later. So you take this as time t is equal to 0. Okay, and velocity is equal to 30 meters per second. Okay, 1
Sir,
second
20
later,
meters.
no, 30. In this case, I have taken it as 30. I know the question says 20,
30.
but in this case, I have taken it as 30. Okay, so
Okay.
at t is equal to 1 second, the velocity will be 30 reduced by 10 meters per second. Why? Because the gravity is pulling it downwards, so it will slow down, and that's obvious to anybody who's thrown anything upwards. Okay, so this will be 20 meters per second. Okay, now at time t is equal to, this whole thing became a bit confusing. Let me remove this part of it.
Also,
I'll make this also a little more clearer. So t is equal to 0 second, v is equal to 30 meters per second. T is equal to 1 second, v is equal to 20 meters per second. Okay, one moment. Yeah. Now another 1 second later, let's say that the ball is here. T is equal to 2 seconds, v is equal to 20, but another 10 has gone down, right? So it will be equal to what?
10. 10.
Units, please.
Oh, meters per second. Sir.
meters per
Meters
second.
per second.
Yeah.
Okay. So I hope this much is clear to everybody. As it moves up every 10 seconds, sorry, beg your pardon, every 1 second, the velocity reduces by a value of 10 meters per second.
Sir,
And
it's
this is
same
common.
same on the right side also, right?
It's common everyday experience. No, the right side, something slightly different happens, right? Coming downwards. But wait a minute, before we get to that, let us concentrate about the t is equal to 3 seconds. Okay, at t is equal to 3 seconds, what happens is that from here, when it is going up, acceleration is reducing it by a rate of 10 meters per second, right? So g is approximately equal to 10 meters per second square. Because of that, what happens is the velocity over here becomes 0 meters per second. Okay, so that is this part. This confirms that at time is equal to 3 seconds, the velocity becomes 0 meters per second. And then the
Sir,
ball starts
but
falling
sir,
downwards. Yeah.
I don't understand what gravity has to do anything. Gravity ka 10 meters per second has to do anything with the velocity being 0.
No. The acceleration due to gravity is 10 meters per second, which means when an object falls downwards, its velocity keeps increasing at the rate of 10 meters per second every second. You know that, right? You don't have a problem
Yeah.
with that. But okay, so give me a couple of more minutes. I hear some sounds of people leaving. I hope it's because of net connectivity and not because people think it's time. Please hang around for a little bit longer. The class is supposed to go till 2:45. So in the same way, when an object falling from up to down, if it increases its velocity by a rate of 10 meters per second, then on the way up, if you throw an object upwards, the reason why it slows down and then comes back crashing to the ground is because acceleration is now working in the opposite direction. Because acceleration always tries to, acceleration due to gravity always brings the object back to the ground, towards the ground, right? So when an object is moving upwards, the acceleration will retard it, it will slow it down. Okay, so that is the reason why it drops by 10 meters per second every second. So if it increases
Sir,
on
so
the
if
way down,
you
it will decrease as it goes up. Yeah.
Sir, but if you have like the from the moment it left your hand, if it's 10 meters per second, then it'll come back after 1 second or what?
Yeah, exactly. I mean, it won't come back after 1 second, it will come back in 2 seconds.
2 seconds, yeah.
Okay, got it?
Yeah, got it.
So one small correction that I have to make is that sometimes you have an imagination that the ball kind of goes to the top and then it stops there for a while before it comes down. Nothing of that sort happens, okay? Because
it keeps going up, right?
Acceleration is continuously working on it. So it reaches the highest point and then it just starts falling. There is no pause at that place, okay? So this isn't Looney Tunes and we aren't Bugs Bunny. So that when the coyote goes off the path, it hangs around there for some time before it falls. Nothing of that sort happens. The ball reaches the highest point and then starts falling down again. And then, interestingly, there is a nice symmetry to the whole thing. When it starts falling, at time t is equal to 4 seconds, velocity again becomes 10 meters per second. But hey, hang on a minute, okay? So here there is a small problem. If you see, when it is going upwards, velocity is a vector, right? So that is why I drew the arrow over here to show that it's 30 meters per second. So let's say it's 30 meters per second here. It goes down to 20 meters per second here. It goes down to 10 meters per second here. It's 0 here, right? And then when it is falling down, obviously it will be 10 meters per second, but pointing in the opposite direction. It will get to 20 meters per second over here, but pointing in the opposite direction.
Plus
It
10
will 30
minus
meters per second, it will point in the opposite direction. Okay. So therefore, yes, exactly. You have to decide arbitrarily, if you like, which direction to take as positive and which direction to take as negative, this time in the y-axis. Okay. So in general, using our coordinate system, the upward should be plus and the downward should be negative. So we can say all of these are plus 10, plus 20, plus 30, and these are all minus. You can of course turn it around and you can call this plus and this minus. That's up to you. But I'm just saying conventionally, this is what we do. Okay.
Sir.
Acceleration, one moment, let me finish because people want to leave now. Acceleration also is a vector. So therefore, you decide whether the acceleration value should be positive or negative, considering that upward is positive and downward is negative. Okay, so think about it and tell me in the next class what you think the direction of the acceleration vector should be. So quickly going down this point. So therefore, this statement, first statement is not exactly correct. The magnitude of the velocities will be the same, though not the direction. So this needs to be tweaked in that way. Velocity
Hey,
v.
wait. So it's saying
Wait,
speed.
wait, wait,
It
please.
says speed.
Huh? You said
It
speed.
doesn't include direction.
Oh, then it's absolutely fine, no problem. Okay, but just the point has to be made. So third point, 30 meters per second at the same hand on the down path. Here I put velocity. I don't know what Sneh said, but if it is velocity, then you must say that the magnitude will be the same, but not the direction.
No, sir, I said speed.
I have the recording, so I can always check it.
Yeah, check.
Decreasing on the way up and
Sly.
way down.
So
That's
sly,
correct.
sir.
Acceleration is 10 meters per second square up and down. But this, of course, the direction needs to be checked. And then after this, these observations are correct, except 1, 2, 3, you can keep it as plus, 0 doesn't have a direction. At 4, 5, and 6, you have to say it is going to be minus 10, minus 20, and minus 30 meters per second, of course. So that way
Sir,
we complete the path. So we'll stop
So
now.
that's how we ended in the last class, right?
Bye,
We'll pick
sir.
up the discussion in the next class.